Okay, we look at 2.5 root of quadratic equation. So we have the quadratic equation ax squared plus bx plus c equal to 0. Okay, so when we solve the equation, okay, we will get x equal to x1, x equal to x2, then that one is the root. Okay, so the quadratic equation we use formula x equal to negative b plus minus square root b squared minus 4ac over 2a. This is the formula. So we get look at three example. If we have an x squared plus 2x minus 8 equals 0, then if we have for this one a equal to 1, b equal to 2, c equal to negative 8. Okay, so for this one, if I put in the value into the formula, then it will become minus 2 plus minus square root 2 square minus 4 times 1 times negative 8 over 2 times 1. So inside the square root is 4 plus 32, 36. So this one is uh, 4 plus 32. Then it will become 36. Then we know that square root 36 is actually 6. Then it will become minus 2 plus minus 6 over 2. Then we will have 2 or negative 4. Okay, we can look at our calculator. Okay, if press the equation, then we have the polynomial degree 2, we have the a equal to 1, b equal to 2, c equal to negative 8. Then we have the 2 and negative 4. So you look at the example, they will return you x1 and x2. That is the root. So if we have the x squared, so this one we call it two distinct roots. So two different roots, two distinct roots. So for this one, we have the x squared plus 6x plus 9. So a equal to 1, b equal to 6, c equal to 9. Then it will become negative 6 plus minus square root 6 squared minus 4 times 39. So this will become 36 minus 36. It will become 0. Square root 0 is 0. So we have the negative 2 plus minus 0. Okay, negative 2 plus minus 0 over 2. So if it is negative 2 over 2 and negative 2 over 2, so we have 2 equal root. Okay, something wrong. Okay, this is not 2, this is 6. Then it's negative 3 and 3. Yeah, negative 3. Ah, for this one, a equal to 1. Before I continue, we look at the equation here. I have a equal to 1, b equal to 6, c equal to 9. Then we have the negative 3 and negative. We have negative 3 only. X equal to negative 3. The calculator won't show you x1, x2. The calculator show you x only. Okay. Then for next one, we have the a equal to 1, b equal to 2, c equal to 6. Then we have the x equal to minus 2 plus minus 2 square, square root 2 square minus 4 times 1 times 6. Then this one is equal to 4 minus 24. Then it comes negative 20. So negative 20 in the normal form in our calculator, negative 20, it will become max error, negative 20. It is max error. Okay. So, but if we use our calculator, okay, we go to the equation here, simultaneous equation, two unknown. So we have the 1, 2, 6. Oh no, we have the simultaneous equation, the polynomial degree 2. Then we have the 1, 2, 6 here. The calculator will give you negative 1 plus square root 5i. And the negative 1 minus square root 5i. Okay, so this one is 0 root. Okay, so from here, okay, the 5i, how can we get the 5i is actually, just now we have the square root negative 20. The calculator returned me max error. But I go to the second mode, that is the complex mode. Now I have the square root negative 20, then it will become 2 square root 5i. Okay, I is what? I is imaginary number. Okay, not real number. Okay, so over here, we can see that what determine the number of root, two real and distinct root, two real and equal root, or no real root, is depend on the discriminant. That is the b squared minus 4ac. So the b squared minus 4ac will determine whether it has 2 or 1 or no root. So the sign of the discriminant, okay, that is the b squared minus 4ac, tell you how many roots are there for that one. So greater than 0, 2 real. Equal to 0, 2 real equal. Less than 0, no real root. Okay. So I will ask my two students to remember this table. So we have the b squared minus 4ac greater than 0, equal to 0, or less than 0. So this one is 2 real and distinct root. This one is 2 real and equal root. And this one is no real root. Okay? No real root. You said 0 real root. Zero no real root is no real root. You cannot say it is no root. No root is not correct, because from the calculator, we can see that the root that we have is complex root. Okay, complex number, complex number, complex roots. Okay, we have the square root negative 1 is the I, imaginary number. So we have the I square equal to negative 1. Okay, because we know that square of the any value will be positive. 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9. Negative 1 square is 1, negative 2 square is 4. Okay, and then negative 2 square is 4, negative 1 square is 1, 0 square is 0, 1 square is 1, 2 square is 4. So we know that the x square is greater than or equal to 0. So there's no number that I square, something square equal to negative value. So there is a mathematician say, yes, there is a value that square is negative 1. That is an imaginary number. It's something that are imaginary. In my imagination, I square is negative 1. So I is square root of negative 1. Okay. So this one is complex root. So these two, we combine, we can say it is has real root greater than or equal to 0. We call it as real roots. Okay. So we have the natural, we have the b squared minus 4ac greater than 0. Then we have the 2 real and distinct root. We know that the graph for quadratic, when the a is greater than 0, it is up concave upward. Less than 0, then is the concave downward. So for this one, 2 real will be something look like this. 2 real and distinct. Equal, then they will touch at 1 point only. Less than 0, then no real root. Okay, it's something like this. This one, I call it always positive, because the value is always positive. And this one, I call it always negative, because all the value is always negative here. Okay, so the curve is entirely above or entirely below the x-axis. Okay, now I will ask you a question. Why the no real root must be look like this? Why I can't draw the no real root graph like this? We cannot draw it like this because we can extend ma. So after we extend, then they have 2 law. So we look at work example 8. Find the value of k has 2 equal root. 2 equal root, then that means the b squared minus 4ac is equal to 0. Okay, so for this one, We start from the given equation here. Okay, we expand it. Then we have the x squared minus 3x plus 6 equal to kx minus 2k. Then I move to the in front and group it. Okay, we have the x squared minus 3x minus kx plus 6 plus 2k equal to 0. So the coefficient for x squared is 1. Coefficient for x is negative 3 minus k. And this is c. So we have the b squared minus 4ac equal to 0. Then we have the negative 3 minus k squared minus 416 plus 2k equal to 0. Okay. So for this one, we want to expand this. Okay, we want to expand this one. So to expand this one, so what we do here is we have the we have 9 plus 6k plus k squared minus 24 minus 8k equal to 0. Okay, the negative 3 minus k, negative 3 minus k squared, if we do it manually, then negative 3, negative k, negative 3, negative k, then I expand, then it will become 9 plus 3k plus 3k plus k squared, then it will become k 9 plus 6k plus k squared. Okay, but actually what I do is when I have the negative 3 minus k squared, both negative, I will assume, okay, I will do it this way. I will assume it is 3 plus k squared. So 3 squared, 9. K squared, k squared. 2 times 6 times k, 6k is in the middle. Why this happened? Because we have this one, we factorize the negative 1 here, 3 plus k, and the whole thing squared. Then we have the negative 1 square, 3 plus k squared. So negative 1 square is actually 1. 1 times 3 plus k, that is the 3 times k squared. So if you know the trick here, so this is very easy. You don't need to do it manually. Okay, you can just assume it is 3 plus k squared. 9 plus 6k plus k squared. Then we have the k squared minus 2k minus 15 equal to 0. So I open the bracket. We have the k, 3, 5, negative 5 plus. So we have the value of k plus 3 equal to 0, k equal to negative 3, k minus 5 equal to 0, k equal to 5. We'll get the answer k equal to negative 3 and k equal to 5. So that is the answer. Okay. So what this answer stand for? Okay, they have two equal root. So you see, we have this one. We check what happened here. If the k is negative 3, then this is negative 3. So I move in front, then it will become x squared minus 3x plus 6 plus 3x minus 2 equal to 0. Then we have the x squared minus 3x plus 6 plus 3x minus 6 equal to 0. Then we have the x squared equal to 0. So x squared equal to 0, then x equal to 0. And x equal to 0 two times. X equal to 0, x equal to 0. Because x squared equal to 0 is x times x equal to 0. Okay, so 2 real and 4 root. And we have the k equal to 5 here. So we have the k equal to 5. Then we have the x squared minus 3x plus 6 minus 5 x minus 2 equal to 0. Then x squared minus 3x plus 6 minus 5x plus 10 equal to 0. Then x squared minus 8x plus 16 equal to 0. So I open the bracket equal to 0. We have the x 4 minus minus. So we have the x equal to 4 for 2 times. Okay, so for these two cases, there are two real and equal roots. Okay, so this is two equal roots. So we want to find the value of k, which x squared plus k minus 2x plus 4 equal to 0 have two distinct roots. Two distinct roots, then that means we have the b squared minus 4ac. We have the b squared minus 4ac that is greater than 0. So for this case, the a is 1, b is k minus 2, c is 4. So when we have the b squared minus 4ac greater than 0, then we have the k minus 2 squared minus 4, 1, 4 greater than 0. Then we have the k squared minus 4k plus 4 minus 16 greater than 0. Then we have the k squared minus 4k minus 12 greater than 0. Then we have the this one greater than 0. 2 and 6 minus plus. And the critical value is k plus 2 equal to 0, k equal to negative 2, k minus 6 equal to 0, k equal to 6. So we have something like this. Negative 2 and 6. Greater than, then we have the 大大小小. Okay, so the answer for k will be less than 2 or k greater than 6. Okay, so for the quadratic inequality, in the IGCSE exam, they seldom come out the question, just ask you for quadratic inequality only. So for the previous part, so now we are in the 2 point, this one is the quadratic and this one is the what which part. So we just now the quadratic inequality 2.4, we can't find a question. Seldom we can find a question simply ask for quadratic inequality. So normally in the IGCSE, they will come out question in this form. Okay, type of root, two distinct root. We have the b squared minus 4ac greater than 0. Then we do it until certain part. We have to solve the quadratic inequality. So this is the answer. So this one they combine the type of root and the quadratic inequality at the same time.